Hi everyone, welcome to our game report. So for today, I'm going to show you later on our game. So the title of our game is what we call Rock Paper Showdown. So with my group mates Josiah Behenting, we will tackle about our game, which is how our game function or how it works. So let's go to the introduction. So, introduction. This C++ program is a simple menu-driven rock, paper, scissors game that allows a user to play against the computer. It includes ASCII art to visual represents each move, making the game more engaging. The program randomly generates the computer's choice, compares it with the user's input, and then display both the results and the updated score. The logic for winning, losing, or tying is handled through straightforward condition checks, ensuring that players immediately understand the outcome of each round. To keep the game organized and user-friendly, the program uses a main menu that lets player choose whether to start the game or exit. The player game function manage all game actions, including taking input, displaying ASCII art, determining results, and updating scores. By using variables passed by reference, the program keeps track of wins, losses, and ties throughout multiple rounds. Overall, the code is designed to be simple, readable, and interactive, making it accessible even the beginners learning how C++ work. So for today, we're going to go down and let's go to the flowchart. So as you can see the flowchart here, so the next supporter for this is the next member, which is Josiah Benting. He will tackle and explain it to you how the flow of our game will works. So that's it.
Sir Ken. So this flow chart shows how rock paper scissors game works from the start to finish. The program begins at start game, and then it shows the main menu so the player can choose what to do. The user is asked to pick an option, and the program checks if the choice is valid. If the user chooses to play, the game continues. But if the user chooses to exit, the program ends. If the user enters an invalid choices, the menu appears again. When the player chooses to play, the game asks the game asks them to enter rock, paper, or scissors. After the user inputs their choices, the program checks if it's valid. If it's not if it's not valid, the user is asked to enter the choices again. And if the choices is valid, the computer randomly chooses rock, paper, or scissors. The program shows the program then shows the user's choice and the computer's choice, sometimes using ASCII art to make it look nicer. After that, the program compares the two choices to determine who wins or if the result is draw. Then the scores are updated based on the result, and the program updated scores are displayed, and the program returns the main menu main menu. So the user can play again or exit the game. And that's all.
Hi there, it's you. It's me again, Asher T. Barredo, the reporter for today. So I'm going to show you our game. So we use ASCII art to show this symbol. Our game is what we call rock paper showdown. So let's go back here in our coding. So the first symbol is rock. The second symbol is paper. And the third symbol is scissors. So we have the game menu. So this game is a simple rock, paper, scissors program where you play against the computer. You choose rock, paper, or scissors, and the computer randomly picks one as well. And the game shows fun ASCII art for each move. Then display the result: win, lose, or tie. It also keeps track of your score, the computer scores, and the number of ties. You can play as many rounds as you want from the menu or exit anytime. So, so I'm going to explain to you the menu here. So, the game asks the player to choose rock, paper, or scissors. The computer randomly picks one of the same three options. Both choices are displayed with ASCII art. The result is decided using these rules. If both choices are the same, it will result tie. If rock beats scissors, paper beats rock, scissor beats paper, players win. Otherwise, CPU. So this is the function of our game menu. So let's go down and we have the results. So we use a bunch of a conditional statement here, and the second reporter will discuss to you how the conditional statements we use, or how many conditional statements we use here, and he will help us to explain this one by one. And that's it. Thank you for listening.
Hello, Sir Kent. So now I will explain the conditional statement that we use in our game called Rock, Paper, and Scissors. Then the first one is if, which means it checks if the user type a number that is not 0, 1, or 2. If the user choose less than 0, then the choice is invalid. And if the user choose more than 2, then the choice is on and then the choice is also invalid. And if invalid, the game prints a message and returns the menu. And another one is if the game compares the player choices to CPU's choice. And the first one is if both choices are the same, then the game will say it's a tie. And another one is else if, means these three lines check all the cases where the player wins, and if any of those is true, then the player will win. And another one is else. If the else it if it's not a tie and not a player win, then the CPU must have won, and the result will say the CPU wins. And another one it is switch, which means the case 1 will the case 1 means start the game, and the case 2 will say exit the game, and the default anything else is invalid. So if the player choose neither of these two cases, then it will say invalid option and try again. Demonstrate our game called rock paper and scissors. I'll run the code. So as we can see, it gives the player two options, which is play game or exit. Now we choose play game, and after I choose play game, the game started and gives me three choices, which is rock, paper, and scissors. And for now I will choose rock, and I won the game and gained one score. Then play again, and this second round I will choose paper, and the result shows it's a tie, and play the game again. And lastly I will choose scissors, and then I won again. Then play the game again. What if I choose always rocks? Then this shows play the game again, rock, play game again, and rock. And the result shows that I gained one score, the CPU gained one score and two ties. So what if, and now I'll choose exit. Then after the player, if the player want to end the game, then the player should choose 2 so that he can exit the game. And that's all. Thank you.